So we're continuing on with our notes on chapter 3, and we're going to talk a little bit about waves. And it feels a little weird to talk about waves because, again, it doesn't seem to fit with the chemistry we're going to review here. But understand that the electron is what chemists focus on. And the electron can behave sometimes like a wave. Not something we're going to talk about in this class, but we are going to talk a little bit about waves and light because we're going to be talking about some spectroscopy in the future. And so you kind of need some more background of this. So this is what we call a standing wave, and this is called the origin of your wave. And so these are the four terms we're going to kind of draw on this picture here to kind of describe what we know about waves. So first thing I'm going to label is the top of the waves. These are called the crests. Note that the distance from the origin to the top of the crest is called the amplitude. Not really going to cover too much about that. Then the distance between each crest is called wavelength. And then the hardest one to probably draw here, I'm going to draw myself standing here, and I'm going to have a stopwatch, and there's me smiling, okay? So I'm going to watch the waves go by me, okay? And so essentially what I am doing is I am counting the waves, okay, counting the crests that go by over a period of time. So that could be seconds or minutes or whatever it happens to be. Well, that is what we call the frequency of how often do you see that crest go by, okay? So for chemistry, we are not going to focus too much on what we call the amplitude, but you could call amplitude the height of the wave. We are going to focus on wavelength and frequency, So wavelength is going to have a symbol. The symbol is called a lambda. And it's going to have the unit of meters, so it's going to be a lowercase m we're going to be seeing. Frequency, you might have learned it from physics, is F, but in chemistry we use this weird looking Greek letter called a nu. It's called Nu, nu. Okay, it's 1 over seconds, seconds with a -1, or you could call it a hertz. Capital H, lowercase z is another unit you see. So I do not care if you use F or nu, but somehow in chemistry books we always use the nu symbol, but I know in physics you use F. So that's a personal preference as to what you want to do, and I will try to write it in my notes as often as possible. So wavelength and frequency have a relationship dependent upon their behavior. So this is what we call the electromagnetic spectrum. I've given this to you in your notes. And what I like about it is it gives the whole spectrum, and it also gives you a nice picture of the wave itself. So over here on the left, you have shorter wavelengths, and over here on the right, you have longer wavelengths. So if we're just looking at the extremes of the electromagnetic radiation, we have gamma rays versus radio waves. And I do expect you to know the order of these because in this class, we're going to be looking at different parts of the electromagnetic spectrum. So do keep in mind that this is the shorter end and this is the longer end in terms of wavelength. It has something called nanometers, which I will talk about here in a second. A nanometer is a small unit of measurement, while meter is a larger. And then we also have hertz down here. Now realize that the hertz are going from a higher frequency to a lower frequency. So why we need to know the electromagnetic spectrum is because we're going to be doing experiments with a spectrophotometer, which is a UV visible range of the electromagnetic spectrum. We're also going to be looking at another spectroscopy called infrared, so we need to know where that is. And then we'll also have another one, the last one that we focus on, is going to involve radio waves. So that's kind of why I want you to kind of look at this a little bit more closely. Now, the only thing I don't like is, of course, this is not in color. So write down red is on the right and violet is on the left. And it does depend upon this symbol, or excuse me, the diagram you're using for electromagnetic spectrum, how they do this. But I do expect you to know red versus violet. So I would expect you to know that red has the longer wavelength compared to violet with the shorter wavelength. And again, this is comparing red to violet, not to anything else. And then we have a lower frequency for red, and we have a higher frequency for violet. Okay, so those two I expect you to know. Those two I expect you to know. Then if you go to the next page, okay, you will see the same diagram, but they've kind of flipped it. Now here I want you to focus on red versus violet, but I want you to look at it the left to right way, meaning you typically write red to violet going from left to right. Please highlight the 700 and 400 nanometers. This is the visible range. And we are going to see this in one of the experiments we're going to do in the future. 400 to 700 nanometers is the range of visible light. And again, it has a picture, it has flipped it. So again, radio waves are on the left, gamma is on the right, however you remember it. And it has a nice picture there. So these nanometers, you may have never used this unit before. But nanometers, 1 nanometer is equal 10 to the negative 9th meter. Or you have a lot of nanometers, 10 to the 9th is equal to 1 meter. And we're going to use this for conversions for our relationships. So for the relationship we're going to look at first in terms of calculation is a very famous equation, which is C is equal to lambda times nu. Again, you want to write it as lambda times F. That's going to be fine with me. But you are going to have to memorize this equation. The reason this equation is so famous is because we have a very famous constant called the speed of light, which is 3 times 10 to the 8th meters over seconds. And you may have already known that. Now this constant I will give you when you are doing calculations. And it is a rounded value. It's like 2.99 something, but that's irrelevant to our discussion. The reason this is so important is if you've paid attention to what we've been talking about here, wavelength versus frequency. As the wavelength gets longer, my frequency gets lower, okay? So that is what we call an inverse relationship, okay? Inverse relationship means as one variable goes up, the other one goes down. And so in order for this to be a constant, you need to multiply those two variables together, okay? So we are going to take wavelength, which is going to be in meters, and we're going to multiply it by frequency, which is going to be 1 over seconds. Well, take a look at the unit, meters over seconds. So when you multiply those two, you're going to get the unit of the speed of light. So we're going to do a couple of these calculations in the next video for you to kind of get the practice. So please be sure you have a calculator out ready to go.